So here we have two problems. One from Devin, who asked, can I help him solve this problem, which is a disk method problem. So I'm just going to walk you guys through this one more time. And then from Michaela and Marina, we're going to do one washer method question. Both of these, we are spinning around an axis of revolution. So in this case, we are spinning the enclosed region around the line y equals 9 for the curve y equals 9 minus x squared, which is the parabola portion. The vertical line x equals 3, so that gives me one intersection point, and then the bounded region above, which is y equals 9. So what we are looking at is we're trying to figure out what happens when we spin this around the line y equals 9. So what I need you all to do is to be able to draw in a representative rectangle to the axis of revolution, and it's always going to be perpendicular. We see that it's a vertical line, so everything is going to be in terms of x. So we're going to write r of x equals my upper function, which is 9, minus my lower function, which is my curve, 9 minus x squared. So if we simplify that, 9 minus 9 is 0, and you get r of x is equal to x squared. To find the volume of this region, we have our pi integral, left bound to right bound, so 0 to 3 of x squared dx. And if you integrate that from 0 to 3, you get, let's jump to the calculator, even if you don't simplify that, integral from 0 to 3 of 9 minus upper function minus lower function squared, 243 over 5, and then we just stick a pi in it. So the answer is 243 over 5 pi. And we know that's a disk because our axis, or our representative rectangle, is touching our axis of revolution. To go to a slightly different problem, this is from a question on the quiz. What happens if we have y equals 7 over x, and then our second equation is y equals negative x plus 8, and revolve around x-axis, which also means y equals 0. So what we need to do in order to do this is figure out what is our big radius and what is our little radius. So I'm going to jump to Desmos. I'm going to turn off these graphs, and I'm going to turn on our second two. So in comparison to our x-axis, which of these functions is furthest away? So we have our intersection points from 1 to 7, so those are going to be my bounds of integration. My big radius is the distance, or the furthest function away from the x-axis. So in this case, that's our green function, our negative x plus 8 minus 0, and our lower function is the 7 over x. So I'm going to redraw, just so you guys have another visual. We had our two intersection points were at 1 and at 7. I had my lower function, which is 7 over x, and my upper function, which was my line. That looks something like that. And that was negative x plus 8. Those two intersection points were at 1 and 7. So the thing that I'm revolving around the x-axis is this green piece. And so if we drew in a representative rectangle, this is the only portion this rectangle right here is the only portion. So our big R would be to the axis of revolution. So that big R would be negative x plus 8 minus 0. And our little r is r of x is our lower function. So in this case, 7 over x minus 0. So our big R in this case is negative x plus 8, and this is 7 over x. We can ignore the 0. So then when we're finding the volume of this washer, we have pi integral from 1 to 7, because those are our bounds. And we have big R squared. So that would be negative x plus 8 squared minus 7 over x squared dx. And all we have to do is type that into our calculator. So we go function, integral from 1 to 7. And then I'm going to put parentheses. Big R squared was negative x plus 8 squared minus, parentheses, 7 over x squared. And then I stick parentheses around both of those, and I type in dx. In this case, I get 72, and I have to remember that I'm going to stick a pi in that answer, so the volume of this shape is 72 pi. So hopefully this is a little clarification on how to do the disk method versus the washer method. The big key is that our representative rectangle, if it's not touching our axis of revolution, then it's going to be a washer.